So just to introduce myself, I'm Ian Sharp. I'm lead data scientist at Oracle. So my career has been Oracle and Microsoft, so obviously double evil corp to the likes of the data science community. And what I'm going to cover off is the ethics of AI and data science. I realised as I put it up there, it's an incredibly portentous title in terms of having an opinion or any understanding of to where this whole thing is going to go. And of course the answer is I don't know. There's a couple of suggestions I've got. One is based around nine-wing planes and the other is based around voodoo. But other than that, I don't really have any too many ideas around this. However, the basis to this conversation, and this is a little bit different for corporations like us, and it's great fun to be able to come along and talk at these events, is that this is not a product pitch. We won't really be talking about technology, but the entry point to this really is, first of all, I'm privileged enough and truly humbled to be Oracle's representative on the Oxford University's Data Ethics Committee. So this is like a cross-party initiative, so Google and Microsoft and et cetera, and IBM and Facebook have representatives on that, so it's hugely interesting. And front and center, the number one issue or the number one discussion point for data ethics is AI across all those companies. So it's kind of useful to maybe sort of share some of the thinking around some of the big technology companies and where we're sort of shaping up into this. And the second entry point is that Oracle's the biggest data enterprise company in the world. So we have lots and lots of conversations. So really today's more about research than anything else, just sort of sharing some experiences, findings, what people are coming up with, what the challenges are, what the opportunities are, and so on and so forth. And this extends beyond relational. So it's the biggest platform for Cloudera, which is a Hadoop system. So hugely proud of our open source heritage. In fact, it was built on Java, is our technology. So we're extremely excited to be doing that. So that's really the sort of entrance point. And the final point is that I'm sort of press spokesman for AI in the UK as well. So that's what we're going to be talking about really in terms of the shape of today. And the entrance point to this really is, as we all know, there's just a huge amount of interest and heat in the media at the moment around AI, artificial intelligence, machine learning, etc., all flavors of that. So I'm not going to recap any of those things here. A couple of favorites in it that I personally have. I don't know if you've come across Homo Deus. I'm sure some of you have, by the Israeli academic Yuval Harari. So it's a super book, so it tackles lots of issues and considerations around thinking machines, machine learning, sentient robots, etc., So I'd urge you to read that. Loads and loads of other ones in this sort of space. My personal favourite, the scariest of the lot, is H.G. Wells' The Time Machine. I don't know how many of you remember that from school. Gave me nightmares. So we'll be talking about sort of context around this in terms of AI, big data, machine learning, and the general ethics debate, and how we can maybe sort of try and shape it as data scientists. I presume most of you are data scientists in this room. I have some angle to data science. Okay, so you'll be on the hook later on when we talk about this. Just a couple of contexts to this though. What we're really going to be talking about is data and the context of the use of data and some of the sort of key issues that we see in this space. I'm not going to touch on any of the political landscapes, the socio or legal considerations. I'm also not going to cover security. Oracle's a vast corporation. I'm not involved in any of those kind of conversations around AI, but this is very much sort of focused on the area of where we're at now. And there's a few sort of things that come out of the conversations that we're seeing. And so I'll touch on these later on as we go through it. Empathic robots, surveillance capitalism, social communication, differential pricing, rise of the grey sheep, and economic hollowing. So we'll talk about some of those cases, and we'll sort of highlight some of the things that we're sort of seeing as drivers in the space. So the first thing to say about this, and I'm just parroting Oxford University, is that the old-fashioned guild has gone. So the barrier to entry for these kind of things has gone. So traditionally, we've kind of sort of maybe looked at skills, technology, budget as ways to inhibit the entry point to any of these areas. And people like Nadella and Larry are absolutely right. So they've long talked about, Nadella talks about the democratization of AI. And Larry's long talked about the fact that every technology since the invention of fire has been used for good or bad. And whether or not we want to sort of kind of control these things, it's really it's pretty much impossible to do, right? So even if we legislate it, it's open source, it's out there, it's ready to go. The closest sort of the closest analogy, I guess, we sort of talked about in the tech world is cloning, right? So we can sort of see an ethical case or an unethical case for cloning. So we talk about, obviously cloning stem cells has a stronger case than cloning dinosaurs. But even if I wanted to clone a dinosaur, it'd be kind of difficult for me to do. I might not be bright enough, I might not have the technology, etc., etc. Clearly these barriers do not exist. So the old-fashioned guild has gone. That's the first thing to say. There is no control over these technologies, like it or not. The second point to make in this space is that the Bank of England Treasurer, Frank Curry, is on a record as saying that in the next 10 years there will be 15 million jobs economically hollowed out through AI. That's the estimate from somebody who does far more calculations than I do. And so clearly, what people are saying there are analogies to the Industrial Revolution in terms of sort of changes of profile. And clearly what people have sort of historically sort of said is that that creates more opportunities for people to learn to code, and that will certainly be an opportunity area in certain cases, but there'll be other things beyond that we'll sort of have to sort of consider and discuss in this whole space. So as we move forward in the context of this, I guess the key thing here is the ethical and non-ethical use of this kind of technology, and that's what we're going to focus on. Just a couple of things really in terms of what we're sort of saying here. I think one of the key things, what I'm just going to sort of do is to talk through some examples of things that we've worked on in the past, some of the sort of good and stronger weak case studies that we've seen in this sort of space. So there's this, when I was at Microsoft, there's a super application here from Holland, which is videoed and highlighted by one of the developers. He's a Brit. He's been blind since the age of 12, and he's got a sort of augmented reality headset that allows him to sort of profile sound. So he's coming out the tube in Clapham. He hears a noise. It's a kid on a skateboard. It profiles that in real time and feeds it back to him. It's absolutely great. He's sitting in a meeting or a presentation like this, and he's talking to people, and it's using an emotive algorithm, an emotion recognition algorithm that profiles using a multi-layer perceptron the attributes of different emotions in people's faces, so you can sort of calibrate how people are reacting. It's a great application for that kind of technology. But similarly, what we see is that the notion of people sort of walking around sort of Sainsbury's and Tesco's with machines watching them, and if you were frowning at a banana or a bag of grapes, then somebody pop out from somewhere and say, are you all right? So there's a fine line here in terms of these sort of technologies. And the essence of what we sort of see is that a lot of the technologies, one of the sort of big challenges that we have is the whole idea of what's called discriminatory algorithms. Okay, so a lot of these things comes down to what's called discriminatory algorithms. In other words, algorithms that decide or discriminate between two areas in terms of behavior and recognition. And this is hugely, so one of the sort of pressures that we get is, well, do we control the algorithms? Do we lock down discriminatory algorithms? And my personal point of view is this is almost impossible to do, because the same algorithm for one use case could be really, really sort of clear, and for another use case could be absolutely dreadful. So I'll give you an example. Any of you work in digital marketing or digital media, so any of you do, then you'll have come across an algorithm called a Cox proportional hazard, which has been around for a number of years. It's the bane of many people's lives, and it's used for digital marketing attribution. It's the big beast on the block. So, bad algorithm. That exact same algorithm comes from a family called survival analysis, which has been used for years in terms of drug research and cancer survival analysis, in terms of plotting people's survival based on different drug treatments and outcomes on that. It's also used in telco churn in terms of looking at plotting how long people are going to stay with your organization. So exactly the same algorithm, the use case and the data that feeds into it is entirely different. So we kind of struggled to sort of see how you can actually classify algorithms as inherently, well, they are discriminatory, but in terms of whether the use case is ethical or not, or otherwise. Here's a really good example here. I don't know if you have come across this. This is a Fitbot that measures your heart rate, your pulse, your etc., etc. And what it does is it vibrates when you're being boring. So basically, it's a boring detector. So you're sitting there, you go like this, and it starts buzzing on your wrist. Sounds a great idea, doesn't it? Who wants to be boring? That would be a really, really bad thing. Nobody wants to be boring. But imagine never being boring. What would that kind of be like? So this thing sort of starts vibrating. Have you ever been with somebody who's never boring? It's exhausting. It's awful. They make you feel terrible. They're always on all the time. And they don't really feel real. And actually, you kind of want to get away from them, and they become a bit boring, really, at the end of the day. And so they talk about sort of application of this, and that kind of sort of feels the right sort of thing. But then the context of who's going to use this, what if it was to sort of get into the risks of teenagers, for example, as one group who are maybe a little bit sort of less sure in their self-esteem levels. They get older, nobody wants to be boring. Well, how is this potentially going to sort of affect those kind of individuals in terms of their behaviour? Do we restrict access around these things? Do we control it? There's a whole bunch of interesting issues around this. Actually, I've always been a little bit critical. We work quite a lot with BBC around, and some of the sort of child mental health authorities around looking at potential bot activity and training activity to help children adapt who are further down the spectrum, who have maybe been sort of damaged by social interactions or technology communications, and maybe sort of create an environment where they can interact with bots and learn with bots, and maybe sort of play off role play with a bot. And historically, I thought that would be like that's really hard, right? In some ways, because if you're in principle, that sounds really good. But what's the corpus behind this? How do we sort of come up with the appropriate data set for which is right and wrong behaviour? Do we use something from our own past? Do we use it from Victorian times? Do we use it from the latest? Do we inform it from the real world, which is Facebook and Twitter and Instagram and so on? Is that necessarily the right corpus to be learning from? So there's all these kind of issues around how we're going to train the data. But the interesting point about this is that some of the use cases, and particularly with sort of younger males that we're seeing coming through, seems to be that they're actually responding better to some of this technology than they are to people. So the empathic robot sort of story starts to come true for certain kind of individuals. We did a whole bunch of sort of social media sentiment analysis, and you guys will know this. So you sort of profile an algorithm, it does some sort of hash matching, strip out all the blank spaces, and then profile your sentiment in terms of how happy you are. So if you're saying awesome, fantastic, great, then you're 0.7. If you're saying lousy, but what we found is that we had to invert the score for teenagers because there was a sarcasm index in that. So every time they used the word awesome or amazing, it was actually the log of that kind of function. But it's just sort of illustrating the kind of principle that we're sort of seeing in this whole space in terms of what people are comfortable with. Again, going back to one of the use cases that we saw before, there's a great one where we're sort of driving through. Again, this is a sort of MS one. You're sort of driving through a McDonald's drive-through on a. It sounds like a Saturday night in Detroit. It's really, really noisy. They're like car horns going off, blaring on. I could barely hear a person talking, never mind what they were saying. But what this does is it takes the WAV file, it does some spectral frequency analysis, it strips that out in real time, feeds through the information as an order to the till, and the guy gets it right. And who's going to complain about this, right? Who's going to complain about this robot application? The guy taking the order, the guy giving the order, etc., etc. So we'll come on to some of the sort of context as to what we feel to be clean, kind of ethical, helpful use cases in a minute. On the other hand, I don't know how many of you heard about a leading airline who offered a pill for long transatlantic flights, and the idea behind the pill, it sounds pretty healthy, really. It's you swallow the pill, you've got a whole bunch of sort of biometric markers in your body, and it's going to monitor, your heart, your health rate, risk for thrombosis, etc., etc. Nobody wanted to take this pill. Nobody wanted to take this pill. Why? Because nobody really trusted. Maybe the pill was massive, I don't know. But even if it wasn't, nobody trusted what people were going to do with this data. What was the reuse for this kind of data in terms of who was going to own it, where was it going to go afterwards. We've done a whole bunch of stuff around gait recognition software. So I don't know if you've come across this, but effectively what you can do is you can profile an individual by how they walk. So if you can't see their face, there are something like 6 attributes of how you move that are all, as unique as a fingerprint to you. Okay. Fairly cool application. But what if I was walking around a supermarket. I was going to say Sainsbury's because it doesn't really matter. It is here. What if I was walking around and suddenly identified that I had a propensity for diabetes from the way I walk? What do we do with that information? Where does that information actually go? Where does it live? What's the right usage of that information? These are kind of fairly major issues. There's a whole sort of area. Again, you guys come across things like Watson and sentiment analysis and those kind of technologies. One of the sort of real challenges that I think a lot of us are finding, certainly we found at Microsoft, was the proprietary nature of making these decisions. So I'll give you an example. There is a motion recognition algorithm. What it does is it takes a video, it analyzes your pixel density in terms of red, blue, green on a map. It identifies your features. It looks at the movement of those features and it correlates that to a range of emotions, to happiness, sadness, etc., etc. So this kind of has a useful or an interesting use for social media analysis, right, in terms of your context of behavior. But with the introduction of GDPR coming along and transparency around exactly, if I sit here and I say Penny looks like a very grumpy elf tonight, whereas Fiona looks like a happy elf, you're going to have to explain how you do that. The challenge with a lot of these technologies is that the IP is wrapped up in the algorithms themselves. So how those algorithms make their decisions is wrapped away. That's where the value is. So going forward, it's going to be really interesting in terms of whether people actually start to make these projections. Oh, and the final one here, this is one of the ones that we're looking at here. This is supposed to be smoke, actually. It's really hard to capture smoke. So one of the applications that we've been involved in is looking at sort of smoke in public spaces and profiling that and then feeding it through into a warning system. So what we can see is good and bad and strong and weak use cases for what we're doing here. I'm going to shift gear for a second because I'm conscious of the fact that I'm running out of time. So when we talk about data science and social media, the two big use cases, the two big commercial use cases we see is content personalization and differential pricing. Okay, and these are the kind of main sort of ones. So I'm just going to focus on these for a while. And one of the sort of phrases that we hear a lot about is the concept of the grey sheep. Have any of you come across the concept of grey sheep? Okay, so this is what digital marketing agencies use to describe people whose tastes are so niche that you can't possibly spot who they are or what they want or where they're going to go. Of course, we're all grey sheep. The challenge with this is, and I should give someone my background. So my first project when I joined Oracle was working with the sort of Gen 2 Amazon personalization engine. So this is the first time we went beyond collaborative filtering. We started to introduce transactional naive Bayes and predictive association. So we actually got a little bit statsy behind this. And it was a kind of fairly major leap forward because effectively the challenge with this whole thing is, as you well know, is you've got a trade-off between accuracy, transparency, the flexibility of the data, the different types of data you're using, the amount of control you've got at the front end, and the compute power, the intensity of that process behind it. So the problem with a lot of these techniques is that actually they're really designed as brute force and ignorance engines. So they're looking at fairly sort of high-grained recommendations and taste settings simply because that's historically all our processing engines and the real-time calibration has been capable of delivering. However, this has dramatically changed. When I worked, I should say, so before I joined Oracle, I was at SPSS, so I was a mathematician in those days. Then I grew a beard and called myself a data scientist and looked for a pay rise. Didn't come, saved money on raises. That's a sad story. But anyway, back in those days, this is like 15 years ago that we first introduced this technology into that space, and it was really, really leading edge. We did some work with the Discovery Channel, who were looking sort of profile to see if anybody who watched the Discovery Channel was interested in anything other than serial killers. They weren't, but nevertheless. This is kind of quite advanced technology for what was happening 15 years ago, and yet we still kind of see most organizations working in this space. And one of the big things to say to your business people is that a lot of these barriers have massively changed. So I'm going to talk about one customer here. Actually, this is the only one I'm going to talk about because they're hugely fun. This organization called the Perform Group. They are the world's biggest digital media sports media company. So in the US, they manage the franchises for baseball, basketball, and football. Over here, it's soccer and cricket and rugby. And they make their money through selling in-game event data to the likes of the tier 1 broadcasters, so Sky, ESPN, BT, those kind of organisations, also the broadsheets, the Guardian, the Times, and so on, and also the clubs themselves. The clubs are becoming increasingly statistically obsessed. So much so that they do this calculation called the golden triangle. So basically what they do is they break up the pitch into thirds, first sector, second sector and third sector. The golden triangle is the final third and the angle between which the supporting midfielder passes through to the attacking two options are there. That's the angle between them, because what they know is that the number of goals between that successful pass goes up higher statistically. There's a guy called David Silva who's like some kind of genius at Euclidean geometry who plays for Man City, because his angles are so it just gives you an idea of how statsy these kind of clubs are getting. They have loads of sort of young data scientists coming through the States, and they all get poached because there's so much money in sport these days. In the UK especially, we struggle quite a lot to hold on to them, because Man City and Chelsea, for example, are really interested in profiling players, not to actually buy, but the resale value of their academy players. That's kind of really where all the money is. It's kind of like a Norland nanny kind of nursery for footballers. And so there's huge amounts of money being moved around in these systems. So it's really hard for them to hang on to these very exciting sort of world that they're working in. These guys worked in a traditional way where they were just sort of collecting. It's great. It's a great job actually. See, for my teenager, effectively what you've got is a bunch of teenagers sitting around with Xbox controllers watching every single football match, and they're tapping in events onto these controllers, and it can be anything from a trivial event like a foul throw or a free kick right through to a goal. The big digital media opportunity here is that they have 23 high-def cameras capturing 25 frame per second events around La Liga matches and sports matches. And the opportunity for them to merge these two streams of data in real time is massive. It's worth millions and millions and millions of pounds. But the problem is that all we know is we've just got an XY coordinate of where the player is and an XYZ coordinate of where the ball is. And if we start to sort of merge these two things in real time and we get it wrong, then their whole brand equity is completely and utterly destroyed. So if Sky getting a feed and they want to know where somebody on the pitch is and it's the wrong guy, they get it wrong, they're absolutely in the dirt. And it's really, really, really hard to do. So when this guy, amazing guy here called, Messi? Everybody knows it. I once did one of these presentations and everybody goes like this, and one guy went, he was the scariest guy I've ever seen in my life. Anyway, you all know Messi. So when this amazing guy Messi does this thing called a nutmeg, and he nudges the ball through somebody's legs, for a moment in time it's actually left control, it's closer to another player than it is to him. So that's actually quite a hard thing to work out in terms of the Soccer behind that. So anyway, we did a whole bunch of stuff around machine learning. We looked at, one of the big challenges here, they have camera failures. All the pitches are different sizes, so you've got guys in bibs hurtling up and down the side. We don't know that from what's going on there. Corners are a nightmare because everybody's piling into the box at the same time and they're moving really, really quickly. So again, loads and loads and loads of scope for error. But by managing, the platform, by getting it to sort of move really, really fast, we're able to sort of help these guys out to the extent that what they now introduce is real-time gambling updates using Scala. So when players move inside the box, that's updated, the odds themselves are updated. It's pretty much, outside of NASA and CERN, it's probably the most insane case study that I've worked on anyway. But so it illustrates the point though that actually a lot of the technology inhibitors that we had in the past for data science saying, well look, it just can't cope with it, don't exist anymore. So my call out to you data scientists is challenge a lot of the sort of rather lazy, or maybe just unaware, there's a much more fair way of putting it, a lack of awareness in the business that actually you can do things better. And if you can do things better, then there's huge amounts of value in this whole area. So, I'm going to talk about ideas now, really. Did I mention 9-wing planes before? I did. Okay, so you know those movies where you see a 9-wing plane crashing off the top of Brighton Pier, and we talk a lot about this in this whole sort of space. And actually, now is the time for terrible ideas. The Kai-bot that we all heard and that got pulled from Microsoft inside a day. In some ways, it's kind of a good idea because we have to learn that these things will go wrong, that we make these kind of mistakes. and things go hideously wrong. The idea behind this is that next time you'll design an 8-wing plane, and we'll move on and forward from that whole perspective. One of the interesting things that I was doing looking at a schools program recently, and they were looking at substance abuse in schools, and somebody was sort of saying, well, could we profile the dilation of pupils on cameras? And I looked at him to see if his pupils are dilated, because I was thinking that's a pretty impressive camera. But in some ways that really doesn't matter, that it's not a feasible idea. The idea is that you get that idea from being feasible, unfeasible, ethical, unethical, legal, etc., practical, of value, of commercial value, of social responsibility, some sort of social responsibility, of some environmental responsibility, through that process as quickly as possible. We're working with the Met Office at the moment, and they're great. These are the sort of algorithm guys, the guys who actually write the weather algorithms. And Antonio says, one of his great quotes is, look, we have 100 ideas and 4 get into production. And when I first spoke about it, I said, so, like an idiot, I said, so you want to reduce those number? He said, no, we just want to get those 4 into production much quicker. So this is the whole idea, and technology companies should really be there to sort of support you getting those ideas into production. One of the things that we're really scared of is the concept of data lockdown. So people stop trusting data. Data doesn't move anywhere. And the reality is, fundamentally, people don't necessarily have a problem with people capturing data on you in a social context. For example, I use Spotify, and I'm sure they're doing a whole bunch of stuff on me. They could be measuring the speed my fingernails are growing, for all I care, because I think there's value in what they offer. They're offering new music that means something to me, and I would have never seen it before. And I kind of trust that they're not going to sell it on to somebody else in that context. So the fundamental issues in terms of data is really about, what are we collecting? Why are we collecting? Are we giving it? Are we selling it? Who are we doing it to? And actually really kind of opening up with our customers about this. There's a really good case study here. Unfortunately, I can't talk about the customer. It's one of our own. And the challenge for them is that it takes them 6 months from a product launch to figuring out whether it's actually going to make any money or not. And the reason that it takes them that long is because they don't own any of the data. The retailers own the data. Now, retailers don't want to give it to them. Why would they? So what they went and did is they created a whole bunch of analytical products, proxy products, and they gave it to the retailers for free through a series of data APIs. Just did this and gave it back to them. Value to the retailers is they saved millions and millions of pounds in terms of understanding what was going on. In return, there's a quid pro quo. The retailers gave that data back to the organization, which was then in turn allowed to reduce its cycle of understanding when they're going to make money or not. So a great case study in terms of just opening things up, creating a two-way win-win kind of scenario around this whole thing. So just some ideas around that. Second one, which is much harder, and everybody gets really cross about this, is the whole sort of differential pricing debate, and nobody really likes this, it's a harder sell. It's much harder sell. So this example, I don't know if you come across this. This is a big insurance company, and what they'd done is they'd done some research, and they'd figured out that people who are more organised tend to crash their car less. So what they decided to do next is profile people's Facebook accounts and look for a correlation between those two. So for example, if somebody like me says, I'll see you sometime this evening, I'm a really tardy kind of slack person, therefore I'm more likely to crash my car, therefore my insurance premiums go higher. If I'm sort of super organised like Becca and I'm going to be there right on point, then the premiums go down. Luckily, Facebook, I think, and all credit to them, shut this down after a day, okay, because it was completely illegal. But let's say that wasn't illegal. Let's say that got through the loop. What would happen? Well, first of all, you'd know all about it. Have you come across a website called Social Cooling?
3020.
Social Cooling.
Oh,
Oh yeah, Social Cooling. It's quite new. It's a great website. It effectively gives a profile of the sort of information that people can can infer from the sort of information they can collect on the web about you. It's kind of fascinating. It's kind of scary at the same time. But let's say, for example, they got through the net here. Everybody would start to know about this. So all that would happen is people would start to mask their behaviour. I wouldn't suddenly become more organised. All I would do is pretend I was more organised by putting these things on my website to drive down my car insurance. So the differential value to the organisation is very, very limited, and all that will happen is that they'll suddenly is that customers will start to think you're a really, really kind of sneaky brand. They're going to kind of creep around trying to find things out about me to gain more money from our transactions. So not really a big win, a long-term win for them. And actually, there are precedents to this. So, the reverse auctions from Ford that we were involved in a few years ago, it seemed like a great idea at first, where you had these reverse auctions from suppliers, and there was a quick buck to be made. There was 30 million, they pulled out of it. But very soon, what we found is that the whole thing imploded on itself, and that organizations were going bust. The whole thing sort of fell apart. So really the idea behind these sort of differential pricing things is that we need to kind of come up with a win-win scenario. Now, it's really easy for guys like me to stand up here and be preachy about this kind of stuff, but it's really, really super tough out there, right? The margins are tight. Organizations are really under huge amounts of pressure. So we hear stories from the airline industry, but I think the margins on an airline seat are $10 a seat, something like that. So it's really, really, really super difficult to sort of be able to do the right thing in the long term. So one of the ideas that we'd come up with is potentially an ethics tax. So maybe if I was wealthier, I would say I will pay a tax on your products so that everybody who buys from your organization will not have differential pricing put upon them. It's just an idea, it may not work in terms of the way that organic food substances work. The idea behind this, though, is that it's extended to everybody, not just the people that can pay for the privilege of having their data used in an ethical context. Okay. So finally, I'm just going to wrap up. How am I doing for time? Ouch. Right. Okay. Sorry, I've massively overrun. Yeah, the final thing I really want to say here is about inclusion, really, because I think one of the, and we're sort of going about the sort of hollowing of the economy. They talk about AI. I think Instagram had 13 employees when it was bought by Facebook, which effectively wiped out the whole of Kodak, which employed tens of thousands of people. Where do those people go? What do they do? Nobody truly knows. But what we have, I think, as a responsibility is to try and find new ways for people to become data scientists and becoming included in this whole thing. So this is something that's really exciting. This is called the Bloodhound. This is a car that's going to drive at 1,000 miles an hour through the Namibian desert. So we're working on that at the moment.
CD personally is awesome.
Yeah, it's amazing. It's being flown over to Oracle Open World next month. So this is amazing. It's really cool. There are 3 initiatives behind this. Interestingly enough, the third most important thing is set a new land speed record of 1,000 miles an hour. The most important thing here is STEM. In terms of sort of creating the next generation of science, technology, engineering and mathematics, because we've seen significant boosts in terms of people and children turning on and being educated by these things. So we're looking for new metaphors and new paradigms for this to work. One of the things that we're all data scientists here, and I get hugely excited by talking about pandas on Jupiter using Python, etc., and we'll all know what I'm talking about. And 90% of the world will go, "What on earth are you talking about? Well, what does this mean?" And that's really a problem, right? Because the whole area that we work in is just way too esoteric and inclusive. Wouldn't it be great if we could extend the paradigm, the metaphor for usage beyond even Excel? I like notebooks. I hate Excel. I find it really, really hard because I think it's boring. And I'm a data scientist. So imagine all those people out there beyond who wouldn't want to touch Excel, a 25-year-old UI metaphor, but maybe are using sort of augmented objects, virtual objects that might become economically viable with data. They just haven't had those kind of opportunities before. And that's sort of something we're pushing forward as we go to this thing. I've absolutely horribly run out of time. The final thing I'm going to say on this sort of thing is in terms of data science. This comes from an organization called Mango. I don't know if you come across them. Really super old school data science organization, so really, really strong. They're based in Chippenham in the city. So they have this online sort of questionnaire. You go and you fill in a whole bunch of stuff, and then it sort of says the type of data scientist that you are. So I kind of come from the modeling side of here. I'm really, really bad at programming. I'm absolutely hopeless. And yeah, not very good at this either, or this. I'm more at that, and I can do a bit of data wrangling. Sean Owen, do you know Sean from Cloudera? So Sean's lead data scientist at Cloudera. His daily rate is $5,000. Sean isn't even a statistician, and he happily admits it. His entrance point to this is through programming, through technology, through understanding those frameworks. So, you know, what we're really sort of trying to say is that we've got to sort of include more and more people into this sort of into these conversations. And actually, going forward, I think if we're looking at the subject of AI and ethical use, then without getting too pretentious, you know, we'll see the roles of psychologists. So, why are we doing this? What's the impact on people? Anthropologists, understanding how people work. Because I think increasingly, you know, as data scientists become more sort of prevalent in this space, I think it's on us to really sort of, you know, maybe sort of drive and control some of those conversations and understand that interaction. So, finally, what am I talking about here in terms of this? So I did mention why this is about voodoo. A number of years ago, I spent some time in New Orleans. It's a great city, amazing food, wonderful music, and of course, there's this tradition of voodoo. In voodoo, they have this concept of what's called gris-gris, which means grey-grey, which means operating between the lines, staying in balance in this sort of thing. And what we really sort of talk about here is maintaining a balanced view through the value corridor. So we're not too much value to the consumer because we'll go bust, and there's not too much value to us because we're going to exploit them. So as we look for these use cases, we're sort of really saying let's maintain our momentum through this sort of value corridor. Let's also look for the opportunities where we can augment human interactions rather than replace them wherever possible. I think we'll find a lot of those sort of case studies out there. So the NHS is probably, I mean, I work with some fairly cool organisations, so you know, we've touched on a couple here. CERN, petabyte of data a second, that's pretty amazing. I'll talk about a couple more later on, Bloodhound, Formula One, all that sort of stuff, lots of petrol head things. My favourite one of all is the NHS. So the NHS in the UK are on record, this is the single coolest big data science application I've come across. The NHS work in prescription fraud, and so they're on. So effectively, what they do is they profile prescriptions and look for anomalies in that data. So one, it's super techy. It uses a single class support vector machine anomaly detection algorithm. So that's really pretty cool. It profiles 90 million prescriptions in the UK in about less than a minute, and it runs about half a dozen algorithms on those things. It's not even a particularly big box. So it's super high volumes. And from that data, there's somewhere in the region of £850 million worth of prescription fraud generated in the UK, which is simultaneously an impressive and very depressing statistic at the same time. But nevertheless, I think it's an absolute pivotal landmark example of how people are operating with machine learning. Machine learning actually is just really reducing that data down to a manageable amount. Then that gets eyeballed by an investigator and says, well, look, is this noise, is this real, or is this something really going on here? So it's an absolutely great use case, and we'll be urging you guys to look at those kind of things. So finally, in summary, what are we saying about this? Well, we can't control and legislate the whole system. It's completely beyond us to do that. It's open source now. We kind of believe that now is the time for ideas, trying things out, failing, building an 8-wing plane next time. But as things get into production, the more sensitive the application is, it's absolutely incumbent on us to be mindful, rigorous, and careful about what we do. The more sensitive these applications become, quick and dirty is no longer a suitable approach for anything around AI and cognitive intelligence. It absolutely will not work. It will harm people, it will harm opportunities. So we must be very vigilant against those. Data scientists need to be bold. You know, we need to stand up to business and just make them aware of what can be done now. So in summary, and again, this comes from Oxford rather than me, it's kind of up to us in terms of deciding what the ethical and non-ethical use cases are. So just to wrap up though, in terms of before we, just to put the context around this, there's some way to go before machines take over the world. So I think that at the moment we're about 5 and 10 years away from having a neural computer that has a billion synapses in a simulation. The human brain has 100,000 synapses, 100,000 billion synapses, I'm sorry. So there's some way to go before we can actually sort of get close to any of these things. And just to give you a context behind, where they work and where they don't, and I think this sort of comes back to probably one of the best stories I'd heard in the past about where this all works. This is an application from Microsoft. Basically what you do is you load up a photograph of yourself and it profiles you in terms of the celebrity you most look like. So I'm the guy on the left and there on this picture. This is the celebrity that I most look like in the world. I couldn't help but feeling a little wounded by this. Absolutely, I swear to goodness, if I'd been taking meth for the next 15 years. So I loaded up a picture of a genuinely handsome movie star. This is who Leonardo DiCaprio looks the most like, this chap here. And actually, when you see how, you've all seen The Bourne Identity, right, and those kind of movies. You see how these sort of things work. It's a multi-layer perception. It's looking at distances between these points here. And what it's not doing, and what it is incapable of doing, and where we have the advantage, is it's not actually looking outside the box. It's not looking context around this. It doesn't look at any of the other things. And I was buying a ticket a few weeks ago in my local station, Bath, and I was getting a massive fuss over a very complicated route. And I went to a lovely lady who was sitting there on the till, and she came up with what it was all about. And she said, the difference between if you'd gone to the machine and done that, you'd have been charged more because we have the capability to think outside the box. And I think going forward, there's the opportunity to be creative, to think outside the box. We have our own problems here. We have bots in Oracle, pre-sales bots that can calculate a 56 factorial combination of the number of cloud products we get, which makes some of our guys very, very nervous. But it was only a matter of time before we do that. Going forward, the opportunity to become creative, to think out of the box, to become more human. Okay, guys, that's what we're sort of saying here. In terms of this is a kind of journey. This is where we're going. The reality is that when we talk about AI and cognitive services and deep learning and all that sort of stuff, that's kind of like sort of manned flights to Neptune, whereas most people in the reality are still struggling to get out the production shed in these things. Having said that, I'm doing this cool project trying to get some data from the outer moons of Saturn with NASA, so if anybody wants to come and talk to me about that, I'll be happy to do that later on.